Thanks for joining the session, everyone. We have Alta Saunders from
Prelexis.
Yes. I pronounce it wrong every time. She's going to be speaking to us about translation of French to a language.
Dyula, it's an African, it's an African language.
Yeah, looking forward.
Yeah.
Over to you.
Thanks so much. Thank you guys. So I'll be talking about how to actually utilize the NLTK library for translation. My colleague that just spoke before me, he started off with saying, being early gives you the opportunity to only be the third best or third worst presentation for the day. So I guess I can be the fourth worst presentation for today, and then it can only go up from here. So the idea about this talk is basically just to highlight some of the functionality within this library and how you can actually utilize it. It is an oldie but a goodie, so you probably know it already. If you do know it, hopefully this just sparks your interest again to go back and utilize some of the functionality. And if you do not know about it, hopefully this also just piques your interest to go and see what it's all about. Sorry, that's just a security warning. So I'll be looking specifically at a case study that I also implemented for Dyula-French. So this was part of a hackathon. And I do think there are some of the workers that work for the company that hosted this hackathon here. I don't know if they're here today, but if they are, they gave me a topic for PyCon, so I was quite grateful for that. Cool. Sorry, there we go. So just to start off, I'm just going to start with a very brief overview just of NLP and just some translation problems that we have. So most of you already know NLP is just it's a subfield of computer science and AI, where we basically look at using machine learning or AI to help us understand human language using computers. But if you are like me, I like simple explanations for everything. So it's the art of making computers understand human language. So like teaching your parrot how to speak. And it's bridging this gap between human communication and computer understanding. And it's behind so many of the tools that we utilize today, including autocorrect, your favorite search engines that we have, virtual assistants, spam filters, and a bunch more, and then, of course, translation. So to kick this off, just to highlight why translation is actually such a difficult problem, I want to start off with a story about how mistranslation actually might have led to the initial search for life on Mars. So in 1877, there was this astronomer, Giovanni, and he noted and made these observations in his notes about canali that he saw on Mars. His notes were later discovered and translated, and this word canali eventually got translated into canals. And this immediately triggered a bunch of people thinking, well, are these man-made? Where are these canals on Mars? And it made a big frenzy for people to start looking for life on Mars. Unfortunately, it was just a classic case of mistranslation, where canali actually refers to trenches. And trenches can be just natural formations that you find everywhere, basically in nature. But nonetheless, this story long outlived Giovanni as well, with us till this day still looking for evidence for life on Mars. So why is translation so difficult? The languages are like fingerprints. Each one is unique, and it has a lot of its own quirks. It's colorful in its descriptions. We have a bunch of idioms that we use, so the meaning is not always literal when we look at it. Context also matters a lot when it comes to translation and language. So words have different meanings based on the situations where they are used in. And of course, we have to consider the cultural differences when it comes to translation. It's not just words. A simple greeting might, for example, mean something in one language, but can be completely something different in a different language because it captures that culture as well. And then a big problem that we have within the translation space is also just the lack of data that we have for this. It's very difficult to actually put together data sets for training, for developing models, for different languages or parallel corpora for this. Sorry, I'm just gonna, sorry, it'll pop up again. I'll say okay then. And then, of course, it's very difficult to create more data sets, especially when it comes to rare languages or languages that are not often spoken or not common in everyday use. So if we just look back in history on how translation was normally done, so of course, we started with humans as the original translators. Next, we moved on to our word-by-word translators. So these are your normal dictionaries that you have if you just want to look up a simple word. It's effective, but it's often simple and misleading because it loses context of the broader picture or story. Later on, we moved on to rule-based translation. So this is where you consider things like morphology, the semantics or syntax, but this requires someone to actually understand the language more specifically. With the age of computers, we started utilizing them and we moved on to statistical machine translation methods. So this is where we use models and basically get the probabilities based on large corpora of languages to find out what the most likely translation is. And of course, where we are today, we have neural machine translation. So this is where we just use deep learning to basically understand language and translate. So there's a bunch of different libraries when it comes to Python that you can actually use for translation and NLP in general. I'll just highlight a few of them and just what they are used for, what the pros and cons are for them. So of course, we have NLTK. I'll be speaking a bit more about this one further on in the talk. But it has a bunch of different features regarding NLP, so tokenization, your parts of speech stemming, tagging, a bunch of different stuff. It is mainly used for educational purposes or when you actually want to do like in-depth NLP exploration or research, but there's a lot of functionality that can be utilized within there. It's very comprehensive. There's a lot of built-in corpora that's available for this. It is a bit older as well. It was developed in 2001, so it is an oldie. Next, we have Spacey, that's more recent. Also, again, a bunch of main features. And you often see this library being used for production systems when it comes to NLP implementations. It's good for large-scale processing. It has a bunch of state-of-the-art models. It's fast and efficient. It also has a really good user-friendly API and great documentation if you want to utilize it. But obviously, with a user-friendly API always comes a limited flexibility, so you have to sacrifice somewhere. Next, we have TextBlob. TextBlob is quite a basic one, but it's good for beginners, so anyone that just wants to kind of play around and see what things are about. It has a very simple API. It's good for basic translation, and like I said, it's just easy to implement. We, of course, have our transformers library. So these days, most people want to default immediately to a transformer model or one of the big pre-trained models that's available out there, and this library can easily help you just to implement those. It does have all our pre-trained models, so all the cutting-edge models that we have available to us. We can't compete with the likes of Google or Facebook when it comes to training these models or having access to data. So it's quite useful to actually go and find models there and implement it using this library. The big thing about this is, however, there is a bit of a learning curve. It's not a fast or simple implementation. So you're not necessarily going to have a quick start if you're new to this field. And then, of course, you're using transformers. Mainly, there's a bunch of different variety of models as well available there. So it can be resource intensive, so you also just need to consider that. And then finally, I just want to mention one of the last libraries. It doesn't have its own functionality. It's Deep Translator, but it's a wrapper for a bunch of other APIs. If you just quickly want to filter through a bunch of different APIs when it comes to translation, this is a great library to use. It even wraps the Google API, and I don't know if you guys know, you can send about 7,000 tokens, I think, a month for free through Google. So if you just want to like play around and see what's available, it's a great place to go. So I'm pretty sure if you were tasked with building a translation model, most people will probably go to a transformer first. Like this would be where we are right now. This is state of the art. And there's very good reasons for going for this as well. But hopefully I can convince you to maybe consider some of the alternatives or have a look at what's available out there as well before just defaulting to this. So when should you consider something alternatives compared to transformers? So they are the go-to at the moment when it comes to translation. They're great for complex translations, high accuracy, good for large amounts of data. But sometimes you just need something different, maybe something simpler, faster, or lighter. And it's worth considering something else. So you should consider something else when speed matters. Maybe you have a limited data set. So this is specifically useful for when you have low resource data or a language that's not spoken a lot. Maybe you have some resource constraints depending on where you want to deploy this or utilize it. Okay, let me do this correctly now. Thanks. And then, of course, if you also want a fast implementation, it's going to take you some time or learning curve if you're not familiar with the transformers to get that going and get something that you actually want to utilize. And then the last reason, maybe you're just like me, you have an M1 chip on your Mac and you don't want to struggle with your environment to access GPU. Maybe think of something else. So this is where the NLTK toolkit comes in specifically for NLP tasks. So the NLTK toolkit is the Natural Language Toolkit. It's a very powerful Python library, particularly when you want to work with human language. There's a book available just on natural language processing with Python, and it also actually highlights a lot of functionality within the NLTK library if you want to have a look. If you're not interested in buying the book, there's also an online version of it available. There's less information in it, but you can still find a lot there as well to utilize. So this library was developed in 2001, as I already mentioned. It is quite an old one, and it was developed as part of a research project at the University of Pennsylvania. And it is very much still used today, mainly for teaching and research, but I do think there is a place for it still in other scenarios as well. So one of the things that makes this library so great is the fact that it has over 50 different corpora and lexical resources available to just use out of the box. So the corpora, when we just speak about that, it's just a large body of text. And the NLTK library has a wide variety on this. So this is where you want to find text on different styles or languages. So maybe you're looking for some Shakespeare text or movie reviews. Maybe you have some books, or of course we have WordNet available here as well. And then when it comes to the lexical resources, this is just a bunch of text, but it has some sense of definition or information attached to it as well. Cool. So some of the most famous lexical resources that we have in here, or things you can use, there's wordless corpora. So if you want to build something to solve Wordle, or maybe do your own spell checker, great place to go. Has some pronunciation dictionaries that you can utilize. And then of course the big one that most people are familiar with is WordNet, where you can find a lot of information. You can find similarities, semantics, synonyms, and a bunch more within the WordNet resource as well. So when you look at the NLTK library, it is a modular library, so there is different focus points for all NLP tasks. So the first one is basically just your linguistic data sets, or this is where you'll find all your corpora as well as all your lexical resources. Then it has a bunch of functionality when it comes to tokenization. So tokenization just refers to splitting text into smaller components. And some of the most popular tokenization methods you have within this library includes just tokenizing on white spaces or words, your punctuation tokenizer. There's a regex tokenizer available as well. There is some language-specific tokenizers, but it depends on the language you want to use. Then it has a lot of functionality when it comes to stemming and lemmatization. So this just refers to when you want to reduce words to their root form. So maybe running goes to run, ran goes to run, and etc. And again, some of the most famous ones or most used ones within here is the Porter stemmer or the Snowball stemmer. Next, we have our parts of speech tagging. So this is really great if you want to label words, so not only for parts of speech, but maybe for some other use cases as well. And then finally, there's a lot of functionality when it comes to translations. There's not only models available for this, but also metrics that you can utilize. So if we look specifically at what's available for translation within this library, I'm going to start off with actually what's available in the corpus. So one of the big comparative word lists we have within the NLTK library is called the Swadesh word list. I don't know if you guys are familiar with this, but this is a word list that has parallel words translated across 24 different languages. So if you want to use something or build something just using a dictionary style type of translation and your languages are available in here, have a look. It might be a quick way to actually just start off on your translation journey. Next, if we look at the translation functionalities that we have, one of the beginning things or classes that you can utilize is something that we just call alignments, or the alignment functionality within this library. And this essentially is just where you align words of parallel sentences. It's often the first step when going further for building a different model. So it's essentially if you just have two words, two sentences, you want to see how well they actually align, because it might give you some indication of whether or not that word actually translates into the word it aligned with as well. There's a few models for translation available within this library as well. So it is statistical machine translation models that we have. So it is some of the older models. It is the IBM version models. I'm not going to go into deep in how they work. But essentially, these models build probability tables based on how likely one word will translate into a different word based on how well they're aligned. And you can see some examples of just what those tables might look like if you look at the translations for your source and target for cat and dog there. It will give some sort of probability score based on the text that it's seen. And then finally, there's a bunch of functionality when it comes to scoring or just evaluating your translation models as well. So of course, we have the Blue score, which is just the gold standard. You'll probably see this on most of the pre-trained models out there, just on how well they do. We have the NSIT score, which is just a variation on Blue, and then the GLUE score, which is similar, but it's better for single sentence translations. And then of course, just a final character level scoring method as well, if you're interested in that. So I'm going to talk about this case study that I did as part of a hackathon. There was a few of us at our company that actually just took part, and we had a bunch of different solutions. So I need to thank them for allowing me to talk about their solutions. But it was a great way to just kind of explore different ways to go about it and see what we can actually see and how they compare as well. So the objective of this competition was basically just to build a translation model for Dyula to French. And it should be able to be, you should be able to use this model on platforms maybe like Discord or something as well as like similar to that. The challenge was, however, that we do have a limited data set. We also could train on GPU, but we didn't have GPU usage for inference, only CPU inference. There was also some quite strict constraints when it came to latency and memory and a bunch of other things as well. The data set, like I mentioned, was very limited. So it is only 8,000 sentence pairs that we had available for this. And we had to optimize for things like inference latency. So we preferred things that might be a bit faster. We also had to consider things like your CPU usage, memory usage. So lightweight models were also preferred for this case. So just a quick background on this language. It is a language that's spoken in West Africa, in Ivory Coast, Burkina Faso, and Mali. It is very closely related to the Bambara language that's spoken in that area as well, and it's part of the bigger Mandi language family. It's mainly a spoken language, so its written form isn't well standardized, and it's actually difficult to get written examples of this language or get a lot of written examples for this language. And this makes it very difficult to actually create a large parallel corpora that you can just utilize for bigger models. Just as an example, if you want to see what this language actually looks like, there's an example at the bottom. So you can see it is quite an interesting language to work with. So if we look at the NLTK study, these solutions are very a broad overview of just what we did. But hopefully it just showcases like the flexibility of what's available and how you can solve them. So for processing, just basic punctuation, lowercase, we didn't do anything fancy there. And then when it came to our tokenizers, because I can't speak French, I can't speak Dyula, it's very difficult to actually evaluate whether or not your tokenizers are doing anything or are worth useful for that language. I ended up just using a very basic word tokenizer. So this just splits it based on the words in the sentence. And then I looked at the next step, which was alignment. So this was essentially taking those parallel French and Dyula sentences and aligning them to see how well they align and do they actually, can we actually make some sort of inference on if the words translate into the other language based on that. The one thing that was considered for this scenario was the fact that you do have different sentence structures when it comes to different languages. So you might have a subject-verb-object or a subject-object-verb as well. So it's something to consider when you actually try and align these sentences as well as possible. You also want to consider where your verb is maybe in your sentence. A sentence can be a sentence with a verb. You don't have to have an object when it comes to a sentence. So because of that case, one of the things we considered was maybe we should just reverse our sentence for Dyula before aligning it to French to make sure we can actually optimize and see where that alignment for the verbs are actually better when it comes to getting it into French. So that's what we did there. And then when it came to the model, we just utilized the IBM model too. So this is the statistical machine model that we had. So this model just, again, builds a probability table based on how well they align. But the version 2 actually looks at not only how well they align, but also where the words are in the different sentences as well. To increase our training data set, we used a technique called back translation. So back translation is where you train a model from your target to source, so basically in reverse. And then you utilize that model to increase your training data set for further training as well. And then the last thing we also did was just looking at the alignment in both directions. So we looked at alignment not only in our source to target, but also in our target to source. And then we actually updated the probabilities accordingly as well, with the hope that if it aligns in both directions, it is most likely that word. And then one of my other colleagues also had a solution for transformers. So basically what they did for that scenario, again, basic preprocessing, punctuation, lowercase, nothing fancy there. And when it came to the tokenization as well as the model, we straight off just went for utilizing one of the pre-trained models that's available. So this is the NLB model. It's called the No Language Left Behind model, originally trained by Facebook. Might be incorrect on that. But yeah, it's available online. It is an open source model that you can actually just implement from there. It is quite big, it is quite bulky. Not all the languages are available in there, but the whole idea about this model is to kind of capture all these rare languages that are often missed if you think about your bigger, like maybe your LLMs or some of the other translators that you have. So because we were utilizing this pre-trained model, we also just utilized a tokenizer. But there was a few steps we did because we couldn't implement the model as is. It's too big, it's too slow. It does not fall into any of the constraints that was put on us. So there was a few steps that was involved. We looked at pruning the layers. So just pruning the model, reducing the number of layers to see if we can get it a bit smaller. There was also a case where we trained a student model based on a teacher. So this is essentially where you just take a teacher model, and you have a similar architecture of another model that's smaller, and you train the student based on how the teacher would respond as well, with the hope that the student becomes as good as the teacher, or acts at least as the teacher, but is a lot smaller. And then finally, one of the last things we did was also just quantize this model just to make sure we can get it as fast as possible and go forward. So we actually do have some rough benchmarks on just how they compared with each other. Just a caveat to this is rough benchmarks just to kind of give you an idea, but it does showcase actually just how these two solutions, very different approaches compares with each other. So first of all, we'll just start with training time. So looking at the statistical models, it was limited training data and all those things, but for the NLTK model implementation, about 15 minutes CPU, no problems, thanks. I just also gave you some just stats just on the hardware that was utilized for this as well. And if you compare this with the transformer implementation, roughly about 9 hours or just under, and it was on GPUs. So there's already a massive gain if you just want to iterate quickly as well. Of course, I'm not going to say implement a translation model using NLTK. We are in a better place where we do have neural machine translation available to us. So they are going to be outperforming everything at the moment. But it was interesting to see how close they actually came. We did use the GLUE score to basically just compare these two performances. You can see neither one of them was great. But yeah, it just goes to show like you can do something simpler, sacrifice on some performance, but it might be useful for other cases. If you look at memory utilization, again, the statistical model, a lot better when you consider like about 20 gigs of memory that you're allowed to use. And then of course, it's much smaller. So you're going from 500 megs to 2.4 gigs for this implementation. And again, if you're just looking at prediction time on 70 of like those examples, a lot faster as well on CPU compared to what the transformer implementation would be. So there's a lot to be gained from maybe just utilizing something different. Again, it depends on your use case. It depends on what you're interested in, but it is worth considering. So I'm just going to end off with some of my final thoughts on this. So translation is a balance. I think there's this quote by Thomas Sowell basically saying there are no solutions, only trade-offs. And I think this is a very true thing to consider with not only translation implementations, but maybe any other of the projects that you actually start. We tend to go for the big things first, or the most popular things first, but sometimes it's worth just stopping and going back and see, well, maybe there's another use case I can meaningful or helpful using a simpler method. And lastly, I hope I just showcased like the power of the NLTK library. If you didn't know already what's available in there, I hope it actually just sparked all the powerful tools that's available within there so that you can go play around and have a look. And then just finally, this field is constantly evolving. So yes, transformers and neural machine translation might dominate at the moment, but there's very much still room for traditional approaches, again, depending on your situation. And I think that's it. Yeah, thanks, Alta.
Hi, sorry. First of all, thank you very much for that. That was incredibly interesting. My question was on the alignment that you showed earlier. I've always been curious about how exactly it does work if in one language you say the 3 words in this order versus in this language it's like completely different. How exactly does the model kind of piece together that, or is it just a case of it's done so many combinations of things that it knows what you're asking?
Okay, so when it comes to the alignment, when we look at alignment, it's just basically on how you tokenize the sentence first of all. So because I did a word-based tokenizer, it was aligned based on words, but it essentially doesn't have any context about the language that you're utilizing or maybe the word order within that language. So if it is very different, I mean, it is what it is, but it actually just literally looks at if this word came first, that word came first for the other language, then they are most likely aligned. And if you have a large body of text and you can iterate through multiple examples, that probability gets updated as it sees those words in other spaces and alignments as well. Yeah. Cool.
Oh, definitely.
Well, awesome talk, by the way. So the big steering problem in South Africa at the moment that kind of hit me when you were giving your talk is, there's a big discussion at the moment around language in the country, available as an example, which I see as a tear down approach rather than build everyone up approach. Given that we've got really awesome digitization programs running with the GNU at the moment in Home Affairs, etc., do you see this kind of project being used to really uplift the rest of the 19 languages in the country so that we can provide first language homeschool for the variety of textbooks and subjects that we have in the country? And having done some homework on the resources, how feasible do you think it would be financially?
Okay. Yeah, so I do think there's a lot of potential for utilizing this within the South African context. We're quite fortunate in a space where, yes, we have a lot of languages, but I think compared to other languages, our languages are like well documented. You actually can find resources on it, even if it's not a parallel corpora for translation from one into other. There's definitely text available that can be utilized. And I do think this tool, you would be able to actually utilize some of the examples I showed to basically help uplift those languages. I don't know how well the models would be at the moment to kind of bridge that gap into teaching in like your first language in schools at the moment. But one place where I do think it can be very valuable is helping with communicating or bridging that gap between people that come from different places or just have to communicate. So if you think about basic things, for example, someone going to a hospital having to communicate, the language, solutions like this, or if you build solutions on our South African languages, it might not be good to capture a complete sentence or something, but it might be good enough to actually just help someone communicate or indicate what is going on. So I think that's where we should start. It's probably not at a space quite yet to completely translate all our languages for school. Yeah. Cool. Thanks.
We have a question from one of our remote listeners. Diana asks, in a previous PyCon, I learned that people use Bible translations to train language models for rare languages. Is that something you would consider, or is it too much work to create translation pairs?
If there's a Bible translation for one language, and we do have English versions of that language as well, it is 100% something I would consider. It would be interesting regarding the context of what it can actually translate, because the language obviously did differ quite a bit, the stories and the context regarding it. But it can 100% be a very useful tool, append with additional resources as well to actually improve this and build it out. Yeah.
Yeah, that's interesting. I didn't know that either. That was thanks to the question asker for educating us. I have a question.
Yes.
How do you? There's standard techniques, but I don't know them. How do you measure the quality of a translation between two languages that you, the creator of the model, don't understand?
Yeah, so this is where those scoring metrics come in that you can implement using this library. I always have a bit of a hesitation when just trusting flat out any statistical measure when it comes to translation, because again, something can be translated in different ways but mean the same thing in the end. But it is the best we have if you don't want to have a human in the loop. But for most cases, I would always suggest like at least have a human in a loop at some stage, just to kind of validate the scoring that you see, because you might be misled based on it. Yeah.
Great. Oh, another question.
So maybe in line with that, are there ways to do grammar checks on the translations here, and maybe to incorporate that into your...
You can do grammar checks, but again, you have to have context regarding that language. So if I think about just the examples I showed, so I don't know if there's any grammar checks or anything available for Dyula, which makes it super tricky, or any resources to actually even build your own grammar checks. For French, there would definitely be. So then you can have a look at that French translation. But again, you still, it can guide you along the way, but the grammar of something can still be correct with still an incorrect translation. So I would always still recommend just have a person, at least at some examples, have a look at it. So.
Cool. Great.
Nice.
Any last questions? If not, let's thank Alta again.
Great, thanks.
That was excellent. I'm sure everyone really enjoyed that. We have about 5 minutes, so if people want to move rooms, they can move rooms, and then the next speaker will be here. Thank you.